bring the next speaker out here in a second, and I'd just like to do a quick introduction for him. He is the head of developer relations and marketing at Skyflow. He'll be presenting on why companies struggle with data privacy, how the top technology companies in the world address these challenges, and how to develop an API for privacy. Please welcome Sean Falconer.
Great, thank you, Stephen. Hopefully technology is holding up this morning, but it's great to be here. So, as Stephen mentioned, I'm going to be talking about this concept of essentially, what is privacy at an API, in particular data privacy. And I think to sort of appreciate the challenge with abstracting something like data privacy into an API, we need to also look at, why is this actually a hard problem for different companies? So back in December in Paris, I was actually at the API Days conference, and I took this picture, which they had in the entryway of the conference, which shows essentially a landscape of all the, well, not all, but a variety of essentially APIs that exist in the world. And clearly we have APIs for so many different things, essentially everything from sending an email, sending a text message, triggering some sort of chat bot, to creating a cat meme. Yet, if you look at this landscape of APIs, there's not actually an API or a category that's sort of defined for data privacy or privacy in itself. So why is that? And a big reason for that is that it's a very complex problem that I think a lot of companies just really don't have a handle on. And I think that naturally makes you ask the question, of course, like, why is this such a hard problem? And I think there's a number of different reasons. Part of it has to do with essentially the kind of rather cavalier approach that we've taken over the last 20 years to how we actually design and develop software. So this kind of mantra that's been popularized by Facebook of move fast and break things is a approach that maybe works really well for sort of rapid application development, but we've now, as an industry, gotten to a place where we've developed these massive systems that address millions or billions of users all over the world, and it's amazing, and we're consuming all kinds of data into these different systems. But we've done that at the consequence of not really stopping to ask ourselves, what are we doing with this data? Why do we need to collect it? How are we actually protecting it? And additionally, we've combined that with essentially a thinking around this data that goes back to the 1980s, when we lived in essentially a disconnected world using terminals that no one had access to unless you were actually at the keyboard of those terminals, where we treated essentially all data the same. Something like a social security number was the same as any other piece of information. It's just zeros and ones, and we kind of just kind of stuff that in some sort of data store. And the combination of essentially taking 1980s level thinking about data and then this approach to the design and growth of different software systems has led to the world that we live in today, where there is essentially a major data breach by a large corporation on essentially a weekly basis. If you go into Google News basically on any Monday and do a search for data breach, you're going to see large corporations every single week reporting or having news headlines essentially written about them of various data breaches and leaks. Just in the last year, we've seen companies like Okta, a little over a year ago, Robinhood, Twilio, Uber. Just a few weeks ago, T-Mobile in the United States had their third data breach in the last 2 years. There's a company called Chegg, which is a startup that had, I believe, their fourth data breach. You can see there in the top left their headline of 40 million users. A few months ago, it was their fourth data breach in the last couple of years. They're now under investigation by the FTC. If you don't know what Chegg does, Chegg is a homework assistance application. So essentially, these 40 million customers were actually 40 million records that have to for children. So it's a really, really scary thing that happens all the time. And I think you are left with this question of, why is it that these companies that are tremendously well-resourced, that have all the tech talent in the world solving really, really complicated problems, still struggle with this fundamental problem? And a lot of that goes back to what I was talking about earlier, this combination of essentially a design philosophy of move fast, break things, and 1980s essentially thinking about data. But also, there's also a really simple answer, which is essentially it's really not their job to solve this problem. If you work at Uber, your job is, how do I deliver a driver to pick up a client as efficiently as possible? And that's kind of what you're hiring your talent for. That's what everybody's thinking about as their prime directive 24/7 within that company. So even in the best case, something like data privacy is going to be an afterthought. And a lot of times we've already built these existing systems, and we've gotten to a place where it's really, really hard to retroactively solve this problem. And we're left with essentially an intractable problem that no one has a handle on. And one of the fundamental problems, which I've been alluding to, is essentially not understanding that not all data is created equal. Some data, and we're talking about sensitive customer data, so these are things like people's names and date of births and financial information, healthcare information, and so on, they simply require better protection than other forms of information. This data is special. It's not the same as a click on a website or on a screen somewhere. And it's similar to how certain physical documents are going to be special. When it comes to things like my passport, my green card, my children's birth certificates, I don't keep those in the junk drawer in my kitchen with my batteries and my flashlights, because my batteries and my flashlights are fundamentally different objects and have different levels of sensitivity than these things like my children's birth certificate. If someone breaks into my home and steals my batteries, it's kind of annoying, but it's not that big a deal. I can replace those. If someone steals my daughter's birth certificate, then not only do I feel like I've failed as a parent, but her information is exposed. Her name, her date of birth, all that information essentially isn't going to change. You can't just cancel it and get a new one. So once that information is out about a customer, it has drastic consequences for those individuals. And of course, for the business, you're losing a lot of trust. You're likely to be fined under the various rules and regulations that exist around the world. And those fines are getting bigger and bigger. So there's tremendous consequences for the individuals that are part of that breach, but as well as essentially the people who, the businesses that are impacted by that as well. So this is a fundamental thing that we really need to understand as a company, or sorry, as an industry, is understanding that this type of data is special and it deserves to be treated so. But even if we understand that, if we continue to essentially architect things the way that we've historically done so, this problem is really, really difficult to solve. If we take a simple example here, where this is, a high-level picture of a modern architecture. Clearly, any modern system is much more complicated than this, but essentially, you have some sort of application front end. Data is going to flow essentially downstream to a database, data warehouse, and so forth. Now, when we collect information, like say someone's phone number, what we end up doing with that phone number is we pass that phone number through these different downstream services, through the API gateway and load balancer, through the backend, database, ETL, data warehouse, and down into some sort of analytics or machine learning layer. And along that way, each of these different services end up, or potentially end up, writing that information into a log file somewhere. And the data is also going to be written into our database and our data warehouse, on purpose, essentially. And the reason this is a problem is essentially you end up with this sensitive data sprawl problem. And it becomes very, very hard to answer basic questions like what data are we storing and where is it stored? And if you can't answer a basic question like what data are we storing, where is it stored, that makes it very hard to know whether it's secure and whether you're actually compliant. And this is a simple example, but here, even in this case, you end up with a multitude of locations where this phone number can exist. So, and it's also going to exist in essentially the database backups and the data warehouse backups. So essentially, it's really, really hard to just like assess where this data is. It's similar to if you imagine, instead of having a single copy of your passport that you keep in a safe location in your home, you made 1,000 copies and then you distribute them all over the place and then try to protect those different locations. That's a much harder problem to solve than having one copy of your passport that you keep in a safe location. But that's essentially what we do with data. We replicate it all over the place, and then we run around trying to essentially protect it. So the natural evolution of some sort of piece of software is you start with something like this. Everybody in your company essentially has, or at least all the engineering team, have access to your production database. You realize at some point that that's a bad idea. So then you lock down the database, but then you also realize, hey, we need some kind of way of creating synthetic data that looks like production data, but it's not actually production data. So you go and you develop some sort of synthetic data generation tool, or you buy some sort of tool out of the box, and you have to lock down each of these systems. And essentially what we're doing is we're adding a bunch of chicken wire and duct tape to an existing broken system. It's like if you put a Band-Aid over a broken bone, it doesn't actually fix and reset the bone. All you've done is add a Band-Aid onto a broken bone. And that's what we're doing as an industry. We've been adding essentially a variety of tools. Companies are going out and they're spending tens, if not hundreds of millions of dollars on 10, 15, 25 different tools to plug holes in this, essentially this dam that has a bunch of leaky that's breaking down with leaks everywhere. And they're just trying to essentially plug those holes retroactively. And that essentially is a losing battle. And that's why we continue to see all these companies that are super well-resourced, super high-tech, not have a handle on this problem. So that's, fairly doomsday, but, turning to the positive here, how do we actually solve this problem? Now, the good news is there are a number of companies, leading technology companies like Apple, Google, and Netflix, and a handful of others that have addressed this challenge through a technology that they pioneered known as the Zero Trust PII Data Privacy Vault. And their key insight, which goes back to what I was talking about earlier, was that they recognized that this data that they store about their customers, which is core to their business, is something special. It's not the same as other types of application data. So what they did was they developed these Zero Trust PII Data Privacy Vaults, and they moved this special data, their customer data, out of their existing systems and into these special locations, creating an isolated single source of truth of their customer data, similar to having that one copy of your passport rather than thousands of copies. And then what that does is it effectively descopes their existing systems from the responsibilities of data privacy, data security, and compliance. Sounds amazing. So we're going to dive into what exactly is a data privacy vault. So a data privacy vault isolates, secures, stores, and tightly controls access to manage and use sensitive data. And a big part of this is based around this principle of isolation. And a well-designed data privacy vault needs to be essentially isolated outside of your existing systems. And this isn't a new concept. If we walked into an office building from 50 years ago, the employee records, the financials of the business, the customer records, and so forth are not just out on the table with the lunch orders for the day. They're at the very least under lock and key within a file cabinet that very few people have access to, or in a larger companies, probably in some sort of vault somewhere. And that essentially is isolation and data governance in a non-digital world. And of course, with modern technology, we can do much better. But a well-designed data privacy vault starts with essentially this principle of isolation. So it needs to live on a segregated network. It needs privileged access. And every access should be logged for auditing purposes, which is required for certain compliance regulations. But also, by logging and knowing exactly what people are doing with the data, we can proactively detect things like data breaches. When it comes to various like criminal type of activity that happens in the world, someone who's determined enough can probably penetrate any system. So we have to assume that something bad could essentially happen. But it doesn't mean that we have to be caught flat-footed and not be able to reduce the risk of our exposure. And what ends up happening today with a lot of companies is someone can be in their systems for 6 months, or a breach could have happened 6 months ago, and they don't actually know until essentially a long time later. And then they're stuck doing PR management and sending out an email to the existing customers, letting them know that there was a data breach. And oh, by the way, it happened 6 months ago and we just found out. That's an embarrassing email to write. But by actually combining things like machine learning with privileged log information of every access point, you can proactively detect things like abnormal behavior or abnormal access of essentially one of your most valuable assets, which is your customer records. A data privacy vault also clearly needs very strong security around it. We need built-in privacy preserving technologies, things like encryption, tokenization, data masking, polymorphic encryption, and so on. This is core infrastructure, so you need high availability in terms of the storage layer, throughput for structured and unstructured data. you need to be able to manage or govern access based around the principles of zero trust. So if you're unfamiliar with this concept of zero trust, essentially you can think of it as no one or no thing has access until you explicitly give it access. And when it comes to essentially data about customers, you should be only giving access to the very limited information that a user or service needs to perform their job. Most users and services don't need access to all information. A customer support person doesn't need access to essentially your entire database of customers. They only need access to the people that are in their queue at any given time. So they shouldn't have access to that, all that. So that by essentially managing access based around the principles of least privilege, you can significantly reduce the scope of a potential problem. And then finally, we store all this data so that we can use it. It's one thing to lock up data and throw away the key, but that's not super useful. So we need support for things like built-in privacy-preserving analytics, database-like access, the ability to run workflows and secure functions directly on the sensitive data so that we can perform all the types of operations that we want to do against sensitive customer information while not actually exposing our systems to the risk of securing it or any sort of compliance regulation. So going back to this problem, this system with problems that we talked about earlier, where essentially the fundamental problem here is we have this sensitive data sprawl. So our customer information just ends up all over the place. And then we don't really have a good way of essentially controlling access or even knowing where that information is. So with the Data Privacy Vault, though, we can solve essentially this problem. So we could take something like someone's phone number or any other type of sensitive data that we want to store about our customers. Essentially what we want to do in a well-designed system when it comes to essentially privacy and security is de-identify that data as early in the life cycle as possible. So when we're collecting information like someone's phone number, we want to essentially send that directly to our Data Privacy Vault, where the Data Privacy Vault is isolated and protected outside of our existing systems and becomes a single source of truth of that data. So here, Pat Smith's record essentially exists only within the vault in terms of Pat Smith's actual customer information. And what the vault can do essentially is create a reference to that data that is a de-identified version of that information in the form of a token. And essentially a token has no mathematical connection to the original data. So it's not like encryption, where if you have the key or you can figure out how to brute force it, you can break the encryption and basically reverse it back to the original data. A token doesn't work that way. You can think of it essentially like a random string. So there's no mathematical connection in this case between this 5551212 number and ABC 123. This is more like a pointer essentially to this original value. So what we're going to end up doing essentially in our downstream services is instead of storing the plain text values of the customer data, we're going to store these references to the original values. So we have essentially ABC123 stored in our database, our data warehouse, any of the backups or replicas that get created. And then additionally, all our log files now, even if we accidentally log some information about a customer, the only thing we're logging is essentially these tokenized forms of information. So even if our log file gets compromised or someone steals our database, all they have access to essentially is non-sensitive data in the form of these randomized tokens. And with the right level of access, you can essentially dereference those tokens back to the original values when you need to re-identify it. But in terms of your backend systems, you now essentially de-risk this entire surface area because none of this surface area is directly touching any of the raw customer data. So in the movie Back to the Future, there's this concept of the flux capacitor, which they talk about as the flux capacitor was essentially the key to unlocking time travel. And when it comes to developing an API for privacy, it's this concept of a data privacy vault that makes an API for privacy possible. Because essentially, once we have this core infrastructure of where we're going to actually store the data and how we're going to be able to use it and manage it and govern access and so forth, then we can essentially abstract that away from the consumer of the data privacy vault in the form of an API, just like you would use an API for any sort of backend service. And essentially that has been what we've been working on at Skyflow for the last 4 years. We just actually had our 4th year anniversary this week. So we're going to start to talk about the evolution of developing an API for privacy in terms of some of the work that we've done in Skyflow. And we'll get into some specific examples and demos of what that looks like. Now, there's a lot of things that go into essentially developing a data privacy vault. As a sort of proof point, Shopify built their version of a data privacy vault. They're one of the pioneers of this technology, but it took them 3 years and contributions from almost 100 engineers to build that. And it was only for essentially solving an analytics use case. So we took inspirations from these different companies, but essentially we built the data privacy vault for everyone else and made it available as an API, but it's a significant lift to do this. So where we started, of course, is looking at how do you actually secure the data. So we know we're going to store customer data that is, regulated and is, highly sensitive. So how can we do that in the most secure way? So our secure data layer, supports tokenization, which we've talked about, the ability to mask the data. So you can get back, the last 4 of a phone number or social security number or whatever sort of format, preserving masking that you need, as well as a technology that we pioneered called polymorphic encryption, which allows you to actually perform operations over fully encrypted data as well. And this is really the secret sauce that makes the data privacy vault able to solve a lot of these challenges around data privacy, including being able to do essentially privacy preserving analytics. On top of that, once you essentially have data secured, you need ways of accessing that as a third party. So you need to develop an authentication service. We need data governance so that we can control access to the data so that not everybody has access to essentially everything. We need the auditing service that we talked about. So how do you log the information? How do you keep track of who's touching the data? You also need essentially encryption key management, which is very, very important. I always say that encryption is easy. Encryption key management is difficult. If you screw up encryption key management, it's like, have you ever been locked out of your house? Well, imagine being locked out of all your customer data and having no way to actually retrieve it because you screwed up key rotation. That is a big problem that you don't want to have to deal with. So essentially, we are able to extract that away also through essentially this data privacy vault as a service. Then you need some way of deploying essentially the data privacy vault so you need some way of through infrastructure to deploying that. And then we need to be able to run essentially secure workflows that can de-identify sensitive data, execute custom code, transform and process data, as well as share data with third-party services. So no company that exists today in the modern era exists purely running on software that only they've developed. They are going to rely on some sort of third-party services where they need to share information, whether that be a CRM or marketing automation platform, or even just sending an email. So you need some way to essentially pass sensitive data to these third-party services without exposing your systems to that. And you can do that essentially through the data privacy vault. And then finally, once we have all these core components of the vault, we can build on APIs and SDKs as the abstraction layer and as the interface for essentially someone who's a non-expert in data privacy and security to utilize all the goodness of the data privacy vault without actually having to understand all the complexity that's going on underneath. So we're going to start to look at some of the specific features and get into a demo, but we don't have time to cover everything. So we're going to specifically look at things like tokenization, masking, polymorphic encryption, data governance, and then essentially how those things work from an API level. All right, so one of the really important things when we are essentially storing sensitive data is how do we control access to it? So we want to lock it up, but we don't want to throw away the key. And we only want to give certain people access via the key, but we also only want to let them access certain information. So how can we do that in a secure way? So what we've developed at Skyflow essentially is a way of controlling access to essentially these tokenized forms. So here we've presumably generated a bunch of random tokens essentially that represent, you can see the first one there, looks like an email, but is not a real email. So these are essentially these pointers or references to the original values that we can store within our database. And what we want to be able to do is make sure that just because someone has access to this token, they can't just call the API and get the original value, or that defeats the purpose of essentially abstracting it away and securing it. So how do we control access to essentially detokenizing this information? So what we've developed is something called a policy-based access control model to control access to being able to perform operations like detokenization. So the types of access that need to happen is either at a user level or a service account. A service account is how you programmatically access the APIs. And a user or service account is assigned a role. And then roles essentially have a group of policies assigned to them. And what we've developed is a simple policy access control language where you can build up rules that state essentially what a user or service account have access to. So since it's a zero trust model, essentially you don't have access to any information until you're explicitly given access. So until there's policies created, any user, service account, or role has no access to no information. And then you can build up these rules like this one where we're allowing the role to read the person's name in plain text, but we're also allowing the role to read the credit card, but only in a masked form in this case. And it's presumably going to be essentially masking the first 12 digits of the credit card and only showing the last 4. And essentially you can build up these policies that will give you fine-grained access control over what the service and user can actually see in the resulting data. So we'll take a quick look at a demo here. So I'm going to jump out of my slides and go over this demo. So here we have a demo of how data governance works. So we have 3 different roles defined: admin, marketing, customer support. And you can see, there's a bunch of data essentially about customers within a vault structure here. And the admin clearly can see everything here. You, of course, wouldn't want to have an admin role with this level of access. It's going to cause some problems for you. But if we look at something like marketing, well, marketing doesn't need access to someone's social security number, but they do need like name and email so they can potentially send that person an email or identify who they are. Maybe they need state for some sort of reason. And for date of birth, they don't need to know how old somebody is, but they might want to know the month and day they were born in order to send them a birthday announcement each year. So these policies on the left here essentially are what control access to the vault information. So we're allowing read on name, email, and state in plain text, allowing read on the social, but it's redacted in this case, and then allowing read on date of birth in a masked form. So pretty simple to build these types of policies really, really fast. And then for customer support, well, customer support needs access to even less information. So they can see name, last 4 social for validating who the customer is, and they can see state, but everything else is redacted. And additionally, this particular customer support agent only has access to people in the state of Arizona. So there's actually a row-level restriction here that says only allow access to the customers that are in Arizona. And this is really important, going back to what I was talking about from the principles of least privilege. Someone who's in customer support maybe that has certain geo restrictions, could be because of data locality rules, like a customer support agent in Germany can only access German citizen information or something like that. Well, then you want those kinds of restrictions in place, but also you want those restrictions in place because say the customer support agent's information gets compromised, well, you want to reduce the scope of the impact of something like that. So if you look at the data breach that happened at Robinhood a year and a half ago, a customer support agent got tricked or socially engineered into giving out their credentials. Those things happen. You kind of have to expect it in the world that we live in. But what you don't have to expect is that that customer support agent had access to 6 million customer records, essentially in plain text. So that level of exposure doesn't need to take place. But if you're thinking about how do we actually govern access around the principles of least privilege, a customer support agent at any given time really only needs access to the people who are in their support queue. So instead of 6 million records, realistically, maybe that's a half dozen or a dozen records that could have been compromised. So that's a significantly less drastic impact to that business and to their customers than 6 million records, essentially. So it's very simple to build up these different policies, and you can do that through APIs. You can also do it through EOI. So that's a very quick introduction, essentially, into data governance. And we're going to take a dive into some more advanced scenarios here. So one of the things that you're going to run into when you're developing like real applications is that a lot of times you need more dynamic access to sensitive data. So what I mean by that is in the demo that I was showing, we had this row level restriction based on state. So in this example, we're restricting the state to California. But if essentially the information about the person's state exists in your system, in your application database, or information exists outside of the vault, how can we essentially pass that data into the vault during authentication so that these types of policy restrictions are based on more dynamic information that we know about who the user is based on our auth model? So essentially, we want this state to be based on an ID that's outside of the vault. And how can we do that? So what we developed in order to support that is something we call context-aware authorization. And here, what we can do is we can create policies that are essentially context-aware, where the value in this example for state is this parameterized context value. And this parameterized context value is passed in during authentication against the API. So here, essentially, we're authenticating against the API, and as part of signing the JOT token, we're passing in a contextual value of, and this is just an example of state, and that state could be pulled from anywhere. It could be, our database or our representation of a user in some capacity, or maybe it's based on IP address or something like that. We're going to pass that in, and then essentially the policies that get activated with the vault are going to respect that contextual value that's passed in. So you can create dynamic access in this way. So as another example, let's say that we want to only allow the person that's logged into our system to have access to their singular row of record within the vault. So in that case, our authentication model for our application could be using something like Auth0, or maybe we rolled our own authentication. We have our own representation of a user, but we want the vault to essentially respect the authentication model. So we can use this context-aware authentication or authorization model to do that. So here we're going to have a policy like to restrict by person ID based on this dynamic context. So what we're going to do from our front-end application is we would use the front-end Skyflow SDK to request a bearer token, the front end is going to make an API request to our back end to generate a bearer token. The back end is then going to communicate with our application database to get a person ID. This is just an example, but that person ID could be Auth0 token if we were using Auth0 for authentication. And then that person ID is going to be added as the context that we authenticate against our Skyflow vault with. So that context value that we showed before is going to be passed in as part of the JOT token. And then we're going to return an auth confirmation and bearer token back to the front end. And now the front end can detokenize data, but it can only detokenize the tokens that belong to this particular person. So even if I captured someone else's token somehow, if I only have access to the singular row and I try to detokenize those values, I won't be able to do it, essentially. So this gives you this combination of both fine-grained control access plus having a way to dynamically respect our understanding at the application level of who that actual user is. Let's take a look at another example here. So a lot of times we want to do something based on the relationship between the user that's logged into our application and potentially other users of our application. For example, a teacher accessing their student records in this example, or it could be a doctor accessing their patient records. There's essentially a business relationship between those two types of users that you know about within your application, but not necessarily the vault understands. So how can we essentially use this context-aware authorization model to make sure that the vault respects our understanding, our business requirements of that business relationship? So in this case, we have two teachers, teacher A and teacher B, and we want to make sure that teacher A only has access to the students in their class, and teacher B only has access to the students in their particular class. So we're going to pass, as part of our JOT token, the context of teacher A, teacher B in this example. We're going to generate that bearer token, send it back to wherever the application is. And then when we need to access student records, it's going to be restricted based on this contextual value. So imagine we have a bunch of student records within the vault like this, and we have some association of teacher ID. Then what we want to be able to do is have a policy where we're restricting access to the student records based on the teacher ID and the contextual value that's passed in. So in this case, teacher A can only access Bob Anderson and Henry Davis's records, and teacher B can access Julie Bird and Sally Smith's records. So we can essentially execute exactly the same, list API call or the same SQL query or something like that against the APIs for the vault, regardless of who the teacher is, but return essentially a different subset of data based on this contextual information. So now we're generating essentially a list of students for teacher A that's only for teacher A's class, and a list of students for teacher B's that's only for teacher B's students. So one of the key ideas here is that this data privacy vault is really making data privacy essentially an architectural decision, rather than what we talked about earlier, that historically is like this Band-Aid that we're putting over like a broken, already architected system. And by making it an actual architectural decision, similar to like using a secrets manager rather than stuffing your secrets in your source code or in your database, you're shifting data privacy naturally very far left. And you're moving essentially from privacy by design, which is a set of principles for privacy, to privacy by engineering. And as long as you're doing that, then suddenly all these challenges around data privacy, data security, compliance, even things like data residency, which we didn't get into today, become as simple as a handful of API calls. All right, so that's the end of my talk today. I don't think we'll unredact that, but thank you very much for listening. I guess we'll get into questions if there's questions. But if you have, if this is something that's interesting to you, or you want to talk more about this, feel free to reach out to me at my email there, Falconer@skyflow.com. I also host a podcast called Partially Redacted, where we talk about privacy and security engineering. There's an episode that came out today actually on AWS Nitro Enclaves. So you can check that out at skyflow.com/podcast. And there's also a community associated with that at skyflow.com/community if you're interested in joining that too.
Sean, that was great. Thank you. I want to remind everyone, any questions you have, please put in the Q&A and we'll get to them. And we do have a few, so I'll just jump right into it. First question, is the policy language standardized, and what is the reference to the standard?
At the moment, it's not. It's something that we created within Skyflow. I think like one of the challenges with typical sort of role-based security models, or some of the types of models that exist, is you end up with in like the level of fine-grained access that we needed. You kind of end up with this challenge of balancing having something that's like powerful enough to essentially satisfy all the types of use cases that you need, and simple enough for essentially people to use. So one direction, if you look at like a typical cloud, public cloud systems like Google Cloud or AWS for creating like roles and policies, it's kind of like point and click, pretty simple to set up. But when you need to deal with more complex use cases, it gets really complicated and hard to manage pretty quickly. On the other side, you could give someone like full JavaScript or Python or something like that to actually like script out policies, but then that's a little bit like taking a sledgehammer to attack. It's just like too much power, and there's no way that a non-engineer could actually build those policies. So we kind of settled somewhere in between of creating this SQL-like policy language, but we haven't gotten to a point where we looked at bringing that forward as a standard.
Cool. So I was looking through some of your stuff, and on your GitHub, you said something that I'm interested in. It says that you're interested in applying the principles of computer science, data mining, machine learning, and statistics to pop culture. Mm-hmm. Please explain this. I also am big into pop culture. I try to use pop culture in a lot of references. I think it helps to explain things to a broad range of people very well. And I noticed you did some of that in your talk, with the Back to the Future reference and all that, which was great. So,
mm-hmm. Yeah. So this has started, I think, primarily as like a hobby of mine that I feel like, as you mentioned, is a way to kind of bridge the gap from things that feel maybe particularly complicated, like machine learning, or in this case, like data privacy that we're talking about, or maybe they seem boring, but when you combine them or mishmash them with things that people are like naturally passionate or interested in, it can become like a bridge essentially. So on my personal blog, which is thefalc.com, I've written a lot of articles over the years that use things like machine learning, statistics, to take kind of a new approach to analyzing television shows. For example, one of the projects I worked on was I developed a machine learning model to analyze the television show Survivor to be able to predict who the winner of the show would be.
Oh, wow.
And I used a combination of like k-means, clustering, and Bayes, essentially Bayes classifiers to do that, and also crowdsourcing data collection, and essentially created like an ETL pipeline to drive and run all this sort of stuff. I've done things on analyzing the optimal gameplay for white elephant gift exchanges, explaining the Monty Hall problem, all these types of things. And a lot of that started when I was on the path of becoming a professor in graduate school, but it's something a hobby that I've kept up since then. And then on the sort of Skyflow data privacy side, one of the demos that I developed was essentially a Star Wars themed demo that allows you to explore and understand the concepts of the data privacy vault and some of the technology that's behind it, while playing essentially a fun interactive game of protecting messages that you're going to send to the Rebel Alliance.
Oh, that's really cool. So I guess my big question is, how accurate was your Survivor predictions?
It was very accurate. And it kind of, I would do essentially live updates. It was on a per show basis. So I do live updates. I did that for like 4 seasons, but it kind of ruined a little bit of the enjoyment of watching the show for me. So I retired it after a little while.
Yeah. What about, have you tried putting that towards like sports statistics and things of that nature?
No, I haven't, but that's certainly, there's a lot of use of AI in both sports as well as any kind of like betting that goes on. There's a lot of combination of machine learning to improve human performance or make more intelligent bets that's gone on for a really long time.
Yeah, definitely. So speaking of machine learning and, especially with like the boom of ChatGPT and everything, how do you personally, leverage AI, in productivity?
So I think like in the context of something like ChatGPT or any of these large language models that are, all the rage right now, I've leveraged them primarily as like an assistive technology, sometimes for writing, or if I don't feel particularly like creative in the moment, sometimes it's a good place to kind of start with, if I know I need to write a summary of something, or I need to create a social media post about a particular article or something like that, then a lot of times I feel it's a good place to start with like crafting that message, and then you can adapt it and put it within your own voice and so forth. But it's a good place to kind of just like get that juice going, or you can give it your idea sometimes, and then it can create like different examples of it. I do a lot of podcast hosting, so sometimes I leverage things like ChatGPT to help me generate like ideate on questions or topics that we might talk about in a particular podcast as well. So I think there's all kinds of different ways of leveraging it. I haven't really explored it as a code assist tool. I know some people have done that, but it's not something I've really experimented with. And I've heard both good and terrible stories about using it in that capacity. So
yeah, there's a lot of mixed feelings going on around it. Yes. Let's switch gears a little bit. So a question came in. This architectural style seems to create and increase the need for data flow management. Do you feel that companies are ready for this? Personally, I don't, the question answer. And how can we get companies there?
So I think the first question was like data flow management. So that's there's something that, the main data flow management you need to be thinking about is, what subset of my data that I'm collecting today is sensitive, and then like essentially diverting that to a different location. And if you're in an industry, particularly regulated industry, that's something that you already have to be thinking about as well. Anyway, even if you're retroactively trying to do this with existing point solutions, which is the historical approach, the first step to essentially building a data privacy program is essentially like discovery. So it's like, where is my data that I'm storing, and what am I storing it? Like, how am I using it? And that's something you can't escape today. If you're doing business in California, you're doing business in lots of different places, Europe, under GDPR, you're going to have to essentially be able to handle things like data subject requests, right to be forgotten. And if you don't know where that data is, you can't essentially solve those types of problems, and you're going to be in violation at some point. So that is a problem you already need to figure out. But a lot of times, depending on, for a lot of businesses, if it's account data, financial data, you kind of already know where the collection points of those information is. So if it's an application, like a mobile app or a web app, there's probably some form where you're already structurally collecting that information. And that's going to pass through probably like an API gateway or some sort of load balancer, and that could essentially be the point where you divert that data into the vault and essentially send the tokens on. Now, the second part of your question was around, is essentially the industry ready for something like this? And I say that there's a couple things. Like, one is that I think there's growing awareness and understanding that companies can't continue the Wild West treatment of essentially customer data. And we're in essentially a paradigm shift right now from the old world of just like store this stuff and do whatever we want with it to the new world where you're going to have more and more regulations. There's over 100 countries have privacy regulations in the world right now, and there's more and more. Australia just released updates where there's increasing fines for essentially violations on compromised user data. So it's something that you can't really escape, and it's heating up more and more. You might be able to get away with it today, but in 3 to 5 years, it's going to catch up with you. And I think the companies that are ahead of the curve on this, that are using privacy as a differentiator, companies like Apple, for example, are the ones that are going to be able to ride this wave and not only survive it, but thrive. And the kind of people who are not on that path are stuck in the old world. They're going to have real challenges in the future.
Yeah, definitely. So in the next question is, the token method does hide the details, but is still a consistent token across uses of that token. How is re-identification prevented?
So there's a couple things there. So he used the term consistent token or consistent tokenization. So there is a concept known as consistent tokenization or deterministic tokenization, which essentially is that given the same input, we're going to generate the same token each time. So every time I take an input of Sean Falconer, I'm going to generate the same like randomized string. So the string alone doesn't carry any information, but essentially I'm going to generate that token consistently within whatever constraints I have around the tokenization method. So I don't know if that's what he's specifically speaking about. So if you generate consistent or deterministic tokens, just like when you use, if you're doing, say, encryption, and you're using the same encryption key for the same input, and you don't have any salt associated with that, and you generate the same output, then there is potentially some leakage or pattern associated with that from just like a data security perspective. It doesn't mean that you have to generate tokens that way, but it all comes with this balance between how secure you need to be and what are essentially your comfort levels with potentially leaking some type of information. There's always going to be like those trade-offs that you need to balance between using it. So for example, like you could take a credit card and generate something called a format preserving token that preserves the BIN number, which allows you to identify which banking system's being used, and also preserve the last 4, and then essentially scramble the rest. Well, there's some information carried with that, but it might be really important for you to have that in order to just like run your business. So there's this trade-off you need to be thinking about. Now, in terms of how do we prevent someone who gets the token from essentially returning it back to the original value, that was a lot about what my talk was about, where essentially you need to be able to have a way to generate an off-bearer token against the API to pretend to be whoever the company is. Mm-hmm. And then, which is either you either have to like compromise the system in some way, but even then, ideally, if the company is doing the right things and the best practices around that bearer token is going to be short-lived and have very restrictive access and not have access. Like it's impossible essentially to create a policy where, a credit card data is going to be in plain text, or highly sensitive values around like, clinical trial records or someone's health records are going to be in plain text. So maybe they're able to compromise some type of information, but then again, it goes back to like, is logging in place? Are you proactively using like machine learning to detect abnormal behavior? Someone like Steven shouldn't be able to access Sean's record. And if you see that, essentially, you just lock that down. But in any essentially like security situation, you kind of need to assume that there could be some compromise, and you need to look at what is the worst case if someone gets to here within my system, and then what's our mitigation scenario essentially. But by leveraging technologies like a data privacy vault, it does simplify a lot of the challenges around how do we actually restrict access, and then how do we limit the impact of someone compromising credentials.
Great. Yeah. I think that answer is satisfied, John. John, if you have any follow-ups to the question, please, put it into the Q&A there. So different topic. I see that you had placed third in the ACM ICDC regionals. I was unaware there was even competitive programming. So this is like fascinating to me. Can you bring us into that? I mean, what's it like, engaging in competitive programming? I'm sure it's very stressful, to say the least. It's you don't have, unlimited time and, everything that you would, in your own environment, I'm sure.
So there's different types of, I guess, like competitive programming competitions. A very famous website, topcoder.com, hosts different types of competitive programming where you're mostly competing as an individual. But the types of ones that I competed in while I was in university were team competitions that are hosted by the ACM ICPC. And essentially every thousands of universities around the world compete in those in different regions. And then the top teams in the world, the top 70 or so, go to the world programming finals where they compete against each other. And the structure of those events was you have 3 people on a team, you have 5 hours, and you have 1 computer. And you're given essentially a set of problems at the beginning of that 5 hours that you've never seen before. And then you have to read through them and figure out if you can solve them or not, and which order you're going to solve them in. And they just give you essentially it's usually like a story that you have to figure out, like, what is the actual problem that you're solving. It's not like write, merge, sort. It's like, a story essentially of like someone's lost at sea and we have this information. How do we actually find them? They give you sample input, sample output, and you have to program that. And essentially all you get back when you submit it is you were right or you were wrong. And
wow.
So if you're wrong, you get a time penalty. And if you're right, you basically move on to the next problem. And it's and the team that does the most problems in the least amount of time essentially wins. So I competed in that and went, was fortunate to go to the world finals twice in my time competing in those. It's a tremendous amount of fun. Takes a lot of practice and work to be able to do it. But it unlocked a lot of opportunities for me, just as building my career.
Yeah, I'm sure. And especially, doing it in that kind of setting, it shows that you have all kinds of just, excellent critical thinking, talents, and that you can work around problems in time constraints. So, I'm sure that comes in very handy when you're actually programming for a project professionally. And, maybe you have a few months to do it, but, it's once you've done it in 5 hours on a smaller scale, it kind of makes the rest seem a little bit trivial.
Well, there's certain things that if you want to be successful in them that you have to essentially develop. Like you need to know whatever programming language that you're working in, like front to back. There's no time to do reference lookups. And generally you don't have access to look up stuff like online anyway. All you had in the old days when I was doing it was you could bring in a binder of printed materials. And I think eventually they even stopped that. So it's just basically what's in your brain. So you need to know if you're in C++ or Java or something like that, every library that you might need to include, you need to just pull that information basically from your mind. And then you need to be able to code all the standard sort of algorithms that you might encounter in like an algorithms class without a lot of thinking, and apply that to a multitude of different types of problems, as well as like do ad hoc algorithm design and so forth. But that's great conditioning for the types of interviews that you're going to encounter at the FANG type companies. And all those companies use these types of competitions as places where they go to recruit talent. So it opens a lot of doors in that capacity. And then as a student, one of the things that it gave me was typically students doing their college classes, and they get assignments. Like if you're taking you have a programming assignment, like the only time you're programming during courses a lot of times is when you have those assignments. So you're not doing that much coding, and it might essentially feel like a big hurdle to tackle that. But when I was doing these competitions, I was practicing programming 20 to 25 hours a week on top of regular coursework. So when I had to do an assignment, it seemed kind of like very easy in retrospect to like challenging myself at that level. So I was able to, something that was challenged, and it wasn't like I was, special or anything. It's just like the practice. You're getting like your 10,000 hours in as a coder on things that are much more complicated to deal with than the types of assignments you're going to see in class. So you can like, just whip through that coursework really quickly.
No, practice definitely makes perfect. You have to constantly keep your chops up and always be working, especially in an ever-changing landscape. That just the tech world in general, you have to always be on top of it. Which actually brings me to my next question. So I know that you, it was called Proven. You built and sold a company that was acquired, which is excellent. I mean, from scratch. So how did you manage, this entrepreneurial side of your life on top of still coding and programming and keeping your chops up? I'm sure that was, I can't imagine what your schedule must have been like.
It was definitely challenging, and I think in the early days of Proven, when we were doing developing the product, I did a lot of the initial product development, and we ended up, we had mobile apps. We had we were a two-sided marketplace. So we had essentially two types of applications on both Android, iOS, and the web. We had two types of applications. I built almost all of that from scratch originally, and then eventually we had teams that I managed that did a lot of the stuff. But essentially, as an entrepreneur, a lot of times what you end up doing is jumping into the parts of your business that have the most pain at any given time. So in the early days is we need to develop a product, we need to ideate and find product market fit, find something that people are willing to buy. And then it's okay, we figured that out, but how do we market it? How do we sell it? All those types of things. So then over time you end up having to focus on the business functions. And that's really, I have my background when I started that company was I spent 10 years basically studying computer science, doing 3 degrees. And so I knew how to build products and engineer. I didn't really know anything about business or marketing and sales, but you're basically thrust in that world where you have to learn those things. And
trial by fire.
Yeah, exactly. So I learned those things because I had to, and there was no one else to do it. So you just essentially learn it out of a lack of resources. And you just essentially, I think that's the key is you just end up focusing on the areas that are the biggest pain at any given time, where you need to do a lot of experimentation and sort of critical thinking. And then over time, when you figure those things out, you can hire talent. If you are really well resourced, you might be able to hire talent to do that. We were never super well capitalized. So most of the time we were taking on those challenges ourselves. But again, I think that by skill stacking a lot of those things for me, that has led to the other types of opportunities I got in my career past that.
Yeah. That's great. Well, we are officially at the end of our time. I really thank you so much, Sean. That was a great presentation. I love speaking with you. Anybody that wants to check Sean out, you can go to thefalc.com, I believe it is. And he's also on GitHub as The Falc. All of his socials are listed on there. Again, really just appreciate your time, Sean, so much.
Yes, thanks so much for having me.